Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Right, so we are going to continue the problems. It is 11th problem from that exercise is given that 1 square into C naught minus 2 square into C1 plus 3 square into C2 minus and so on. All the terms are given. Okay na? So while you are observing here, C naught, C1, C2 are nothing but NC naught, NC1, NC2 and so on like that, right? So one is plus, alternate symbols are plus minus are coming like that. So alternate terms are having a different signs. Okay na? Right. Now while you are expressing this one, we can write it in the form of sigma r equals to 0 to n. So r value I am taking 0 to n. For getting that 1 square, I am taking like r plus 1 whole square. That means when you substitute in the place of r as 0, that means first term is r0, no? So if you take 0, 0 plus 1, 1 square, c naught will come. So here cr. Okay na? And for getting the negative value, we should take minus 1 whole to the power of r. That means if you take r power 0, anything power 0 will be 1. If r power 1 will be minus 1, r power 2 again plus 1, like this will come. Okay na? So actually we can write minus 1 to the power of r. That is equals to sigma r equals to 0 to n. Now I am writing minus 1 power r, and this r plus 1 whole square I am going to express as, that means it is in the form of a plus b whole square, no? So I am just expanding like r square plus 2r plus 1 into cr. Okay na? Right. Now the three terms I am writing like sigma r equals to 0 to n minus 1 power r. Now r square into cr plus 2r into cr, I am just separating for each and every term. 3 terms will come because 1, 2, 3 terms are there, no? 3 terms I am going to multiply with cr. So the first one will be r square cr. Again plus term 2 into r. So 2 into sigma r equals to 0 to n r into cr plus, so here minus 1 power r will left here. So let me write minus 1 power r, minus 1 power r, r into cr. Okay na? Plus sigma r equals to 0 to n minus 1 power r, 1 into cr is cr. So there are 3 different terms are coming. I just apply the 3 different terms with sigma r equals to 0 to n. Okay na? The next step is sigma r equals to 0 to n minus 1 power r. R square I am going to write as r into r minus 1. Then what will be r into r square minus r. So minus r I have written, no? So I am just adding plus r also into cr. Plus r I am adding, that means r into cr if I am adding this one. So this is also r into cr term only. Here already 2 terms are there. So if you add one more term, there will be 3 terms. Sigma r equals to 0 to n minus 1 power r and rcr plus sigma r equals to 0 to n minus 1 power r and cr. Okay na? Right. Let us check this one. R into r minus 1 cr. How can we express this r into r minus 1 cr? Let me check. If I am just substituting in on the place of r 0, 0 into something, everything will be 0. So r equals to 0 to n is not possible. Now let us check r equal to 1. So 1 minus 1 becomes 0, 0 into remaining term will be 0. So we can left. So r equal to 2 is possible. So r equals to 2 to n minus 1 power r into r minus 1 cr plus, here let us check that r equal to 0, 0 into c naught becomes 0, so it is not worth it. So r is equal to 1, you substitute, we will get it. sigma r equals to 1 to n minus 1 power r into rcr plus here r equals to 0, c naught becomes 0, r power, yes, it will be worth it. 0 to n minus 1 power r, because in the power of r if you take minus 1 power 0 becomes 1 only c naught, 1 c naught we can write. Like this 3 terms are coming, so let us try to simplify this. But here we need to use the formula like, see r is equal to 2 onwards while you are writing that, r is equal to 2 r into r minus 1 by cr. Okay na? So this one we can write it as, I am just applying here. So from the 3 terms I am just going to take, yeah, r into r minus 1, no? Now in the place of r I am just trying to take n. In the place of r I am just trying to take n. So n into n minus 1, okay na? N into n minus 1. Clear? So that is equals to sigma r equals to 2 to n minus 1 power r, that is in the place of r we can write n into n minus 1, and here what will come, cr, that means c 2 onwards we should take, that means n minus 2 c n minus 2, okay na? Right, because nc2 or n into n minus 2 both are same, because we know that ncr equals to nc n minus r. If you take in the place of r, if you take 2, nc2 and nc n minus 2 both are same, no? So that's why in the place of 2 we can write n minus 2. Okay na? So plus next one, 3 into sigma r is equals to 1. So this one we can write it as 3 into this one minus 1 power r, sigma r equals to 1 to n minus 1 power r, we can write n into n minus 1, right? Here r minus 1 will be there, no? Sorry, r term will be there, no? We can write n into, we can write this one n into c1, that means n minus 1 c n minus 1 we can write, okay? And last one, plus sigma r is equal to 0 to n minus 1 power r into sigma r, or sorry, cr, plus sigma r equals to 0 to n. So it will be, we can write it c naught or n c naught minus 1 power r c naught. Okay na? Now I am just taking the common n into n minus 1. Okay na? So here this one I am taking like from the first term, n into n minus 1 I am taking as a common term. Still what is remaining, sigma r is equal to 2 to this one, we can write nc2 c naught, that means 2 if you substitute, nc2 c naught plus n minus 2 c1 plus n minus 2 c3 and so on will come from the only first term. Okay na? Next from the second term, this one 3 into, we can write this one as 3n I am taking common here. Okay na? 3n I am writing here, n minus 1 into c n minus 1, no? So from this we can write n minus 1 c naught plus n minus 1 c1 plus and so on we can write. And the last one is, this value becomes, if r equals to 0, if you substitute to 1 into 0, 0, c naught value 1. Okay na? Or yeah, nc naught, no? So it will becomes 0. Right. Again this one, first one n into n minus 1. So here while you are observing here, why I am writing the 0 here? Because minus 1 power r means c naught minus c1, that means when you expand this one, c naught minus c1 plus c2 minus c3 and so on will come. Now we know this one here, here to here while you are observing, all the coefficients, sum of all its coefficients becomes 0, because alternate symbols also there, no? Minus 1 will be there means here minus term will be, second one is minus, third term plus, fourth term is minus, like this will come here also. Okay na? we know sum of all coefficients, nothing but, that means C naught, C1, C2 and so on like this. Cn we can write 2 power n, but C1, C3, C5 and so on like this 2 power n minus 1, and same way C0, C2, C4 and so on will be 2 power n minus 1, but all together like C0 minus C1 plus C2 minus C3, that means sum of even sum of all together with the different symbols we are taking is equals to 0. Same way here also it is becomes to 0 plus 3n into 0 plus this one also 0. So n into n minus 1 into 0 becomes 0, 3n into 0, 0, all zeros only. So when you add zeros like this, you will get answer 0 itself. Yeah, once you look at this one, how I am doing this. First one, I am just trying to express into the sigma values like r is equal to 0 to n, r plus 1 whole square. To get that 1 square, 2 square, 3 square values, I am writing that r plus 1 whole square. That means if you take that r value 0, 0 plus 1, 1 square. R value 1, 1 plus 1, 2 square like this, minus 1 power r, because alternate symbols are negative. So afterwards I am expanded like a plus b whole square format, then divided into 3 parts, 3 different expansions I have written. Finally we will get that answer is 0. Okay na? Now let us go to the next problem. Yeah, problem number 12. Yeah, 12th problem is given that, the value of sigma 1 less than or equals to I less than j less than or equals to n, sigma of sigma 1. So here you should remember 3 formats, that means 3 conditions will be here. The first condition is sigma, this one only, 1 less than or equals to I less than j less than or equals to n. Okay, na? In this situation, Ci, Cj, let us take Ci, Cj, we are writing like, we are having a formula like sigma I is equals to, I is equal to 1 to n, I equals to 1 to n, sigma j is equals to 1 to n, this is Ci, Cj minus sigma I is equals to 1 to n, sigma j is equals to 1 to n, Ci, Cj whole square, that means Cr square we can write. Okay na? Or NCI, Cij whole square by 2. This is the formula. So one more condition is, if you take all of them are equals to like this, middle plus symbol will come. And last third case, if I and j are not equal, then the same format will come like this only. Okay na? There are the 3 formulas, but here we need only one formula is required actually. So let us see this. So for this, according to the format, we can write sigma I is equals to 1 to n, and sigma I is equals to 1 to, j is equals to 1 to n, 1. First one only 1 will be there, minus sigma I is equals to 1 to n, 1 square. So this term will be haven't taken as a square number. Okay na? So divided by 2. Now let us see this. The first term is leave like this. Here sigma n. Sigma n means n times we should add 1 plus 1 plus 1, because there is no variable here. In the place of 1, if we have n, in the place of n we can write 1, 2, 3. 1 plus 2 plus 3 plus 4 like this will come. But only here constant will be there. Constant means 1. That means 1 plus 1 plus 1. How many times we should add? N times we should add. Okay na? That means simply n will be the answer for this. That means sigma I is equals to 1 to n. The answer is n minus sigma I is equals to 1 to n. 1 square, nothing but 1 square plus 1 square plus 1 square like this will come. It is nothing but n square. Okay na? Have you checked this one? Yeah, divided by 2. That means we can remove that sigma value because we already substitute the value here, n square by 2. Now again sigma is equal to 1 to n. That means in the place of n we can write 1, 2, 3, 4. That means 1 plus 2 plus 3 plus 4, like this will come. That is nothing but 1 plus 2 plus 3 plus and so on plus n minus n square by 2. Okay na? Yeah. Now we know that actually 1 square is nothing but 1 itself. So we can write again same thing is n here. So we can take it as n. Okay na? Sum of first n natural numbers formula n into n plus 1 by 2. Here already we have 1 more 2 minus n. Try to simplify here. N into n square plus n minus n by 4. So plus n minus 1 can be cancelled. We can write n square by 4. But while you are writing this, divided by 2 is not completely for this one. So here there is a small mistake in the calculation like this. Yeah. Now I am writing here, see the first term in this place of 1 to n we can write n into n plus 1 by 2. Here minus n, this minus n whole divided by 2. Okay na? Now this one n into n square plus n. 2 into minus n is minus 2n divided by 2, and denominator also 2. 2 into 2 4 will be. So it can be written as n square. N minus 2n is nothing but minus n by 4. That is equals to n into n minus 1 by 4 will be our required answer. Okay na? If you take n common. Or else, okay, one second. Here 1 square in the place of 1 square, let us try to apply n square, because 1, 2 we are getting extra here. So n square, here also n square will be, here also n square will be. Now, yeah, let me write this one. N into n square plus n minus 2n square by 4. So while you are observing here, n square minus 2n square becomes minus n square, in before n will be divided by 4. So here take n is common, then 1 minus n by 4. This will be the answer. Let us check the answer. Again same answer came, I think so, right? Okay, let us think about it later. So let us continue the problem. I will come back again. Okay. So 13th problem here. The problem is given that the general term of 2a minus 3b whole to the power of minus 1 by 2. So what is the general term, like 2a minus 3b whole to the power of minus 1 by 2. So first of all, let us try to write in the form of 1 minus x whole to the power of minus n. Okay, na? So that means here I am taking 2a as a common term. 2a whole to the power of minus 1 by 2 into 1 minus 3b by 2a. That means I have just taken 2a as a common term, whole to the power of minus 1 by 2. Okay. So that is equals to, we can write whenever it is negative in the exponent, we can write in denominator. That means 1 by 2a whole to the power of 1 by 2. Okay, na? And it is in the form of 1 minus x whole to the power of minus n. That is nothing but 1 plus nx plus n into n plus 1 by 2. That means minus into minus means plus will come. n into n plus 1 by 2 x square plus n into n plus 1 into n plus 2 by 3 factorial into x cube, like this will come. Okay na? That means 1 plus n is nothing but 1 by 2. 1 by 2 into x value is 3b by 2a plus n into n plus 1 by 2. Let us check the options. Yeah, or else we can use the direct general term formation also, or formula also. Let me use the formula here, tr plus 1 formula, general formula. General form tr plus 1 equals to, we can write this one, n into n plus 1 into n plus 2 and so on, plus n into, n plus r minus 1 by r factorial into x power r. This is the general form. Because both are minus terms means all increasing order will come. Yeah, from this we have extra term here, that is 1 by root over 2a into n is nothing but 1 by 2 into 1 by 2 plus 1 into 1 by 2 plus 2 and so on will come 1 by 2 plus r minus 1 by r factorial into x power r. X means what? X means 3b by 2a whole to the power of r. Okay na? That is equals to 1 by root over 2a, and here while you are observing this one, 1 by 2 into 3 by 2 into 5 by 2 plus and so on will come. Okay na? So this one 1 plus 2r minus 2 by 2 by r factorial into 3 by 2 whole to the power of r into b by a whole to the power of r. Okay na? So numerators 1 into 3 into 5 like that, denominators 2 into 2 into 2, like how many times? R times. So 2 power r will come as it is again. That is equals to 1 by root 2a, 1 into 3 into 5 and so on. Denominators 2 power r into r factorial, and here 3 power r by 2 power r into b power r by a power r. I just separatedly written like this. So it is in the form of 2r minus 1. When you simplify this one, it will come 2r minus 1. Okay na? Right, that's it. This is the answer. So the option, I think so it is, yeah, fourth one I think so. Yeah, third option. So I am using the general form like this. Let us go to the problem number 14. The 14th problem is, yeah, if x is so small that x square and higher powers of x may be neglected. That means x value is very small, so whenever you see the x square term and more we can remove, until x we can write. Okay na? So 14th problem is given that, so neglected, then 1 minus 3x whole to the power of 1 by 2 and 1 plus x whole to the power of 2 by 3, and the denominator is given 1 minus x whole to the power of 1 by 2. I am writing in the numerator 1 minus x whole to the power of minus 1 by 2. Okay na? So try to apply the formula like this. It is in the form of 1 minus x whole to the power of n. N is positive, here negative, positive, alternate numbers will come. That means 1 minus nx, right? When you expand this one, 1 minus nx plus n into n minus 1 by 2 factorial into x square, like this will come expanded when you expanded like this. So 1 minus n value is 1 by 2 into x value is 3x. we cannot write that x square because it is already neglected. X square we can leave it. Now same way this one. 1 plus, yeah, both are plus terms, so plus terms only will come, n into 1 plus nx plus n into n minus 1 by 2 for like same format, but plus symbols will come in between. So 1 plus, here n value is 2 by 3 into x. And the last one, both are negative terms, means increasing order will come. That means 1 plus 1 by 2 into x. Like this 3 terms are there. So try to multiply 3 of them, and x square and above powers we can neglect, only x we can reveal like this, leave like this. So this one 1 minus 3 ones are 3, 3x by 2, 1 plus 2x by 3, here 1 plus x by 2. Okay na? So first two I am just going to multiply with 1 into this term, with 1 into these two terms, as it is both the terms will come. Now minus 3x by 2 into 1 minus 3x by 2 minus into plus minus 3 by 2 into 2 by 3, that means 6 by 6 x square. While you multiply first two, binomial into binomial, will get the terms like this. And the last one I am leaving like this. And here we can neglect this square term. We can, x is very small, so x square and more powers we can neglect. So we are leaving that. What about the remaining here? That is equals to 1 plus. For these two, try to find LCM. 2 2s are 4x, minus 3 3s are 9x by 6. Okay, na? Plus 1 plus x by 2 into 1 plus x by 2. Now this one, 4x minus 9x is minus 5x. So 1 minus 5x by 6 will come into 1 plus x by 2. Again try to multiply binomial into binomial terms. So 1 into this term, same term will come, 1 plus x by 2. Now minus 5x by 6 into 1, minus 5x by 6, and minus 5x by 6 into x into x square. Third term, fourth term I am leaving because it is x square. X square and more powers we can neglect, right? So until here is enough. So try to simplify this one. LCM is 6. LCM is 6. 6 into 1, 6. Plus 2 table in 6 3 times. 3 into x is 3x. Minus 6 7 6 1 time, here 5x. That is equals to 6 minus 2x by 6. Take 2 table as a common. That means 3 minus x by 6. After cancellating, we'll get 3. So simply 3 minus x by 3. That is, I am writing separate like 3 by 3 minus x by 3. 3 cancel, it will be 1 minus x by 3 is our required answer. Okay, na? 1 minus x by 3 is our required answer. Please check it. Option 1. Let us go to the problem number 15. Okay, no? Yeah. Question number 15 is given that sigma r is equal to 0 to n minus 1. Sigma r equals to 0 to n minus 1. And NCR by NCR plus 1. NCR plus 1 whole cube equals to 4 by 5. This entire value equals to 4 by 5 it seems. Okay, no? Let us see this. While you are observing the denominator, it is in the form of NCR plus NC r minus 1 is equals to n plus 1 CR. Okay, now same concept we can apply here. Sigma r is equals to 0 to n minus 1. Numerator is NCR by denominator. See, n's are same. Here r plus 1. Next one. That means n plus 1 CR plus 1 will be whole cube, that is equals to 4 by 5. Okay, no? Right. Next one, that implies sigma r equals to 0 to n minus 1. This one, NCR by n minus 1 CR minus 1 will be the formula of r plus 1 by n plus 1 whole cube. That is equals to 4 by 5. Okay, now I am just applying the power separately. That means r plus 1 whole cube by n plus 1 whole cube. We can, whenever you see the r value, you can substitute 0 here, but not in n. Okay, that is equals to 4 by 5. Now check here. Now I am trying to apply the 0 here. In the place of 0, 0 plus 1 whole cube, numerator 0 plus 1 whole cube, plus 1 you are applying this, 1 plus 1 whole cube, next 2 plus 1 whole cube, and so on. Last one is n minus 1, n minus 1 plus 1 whole cube by all of them having the same denominator, n plus 1 whole cube. Okay, so 0 plus 1 is 1, 1 cube value is 1. That means simply 1 cube plus 2 cube plus 3 cube plus and so on plus n cube. So while you are observing, this is nothing but sum of the first n cube numbers. Sum of the first n cube numbers. Sum of first n cube numbers formula is first n cube numbers. Formula is n square into n plus 1 whole square by 4. This is the formula for first n cube numbers. But in that answer we should write n square into n plus 1 whole square by 4, and already denominator we have n plus 1 whole cube. Whole square whole cube n plus 1 times. Because your numerator is 2, here 3. That means 1 time will be remains. That is equals to n square by 4 into n plus 1, and this is all values are equals to 4 by 5. Yeah, these values are equals to 4 by 5. That is equals to, I am just dividing 4, I am transposing that side, it is going to multiply in the numerator. So this will be n square into n plus 1, n square into n plus 1 equals to 4 into 4 by 5. Next check here, if you take n value 4, n square means 4 into 4. Here 4 plus 1, 5. So simply n is equals to 4. N value equals to 4. That is our required answer. Okay, now? So let us move on to the next problem. Problem number 16. Okay. So let us see, the 16th problem is, the coefficient of x square in 1 plus x whole square, coefficient of x square in 1 plus x whole square into 8 minus x whole to the power of minus 1 by 3. 8 minus x whole to the power of minus 1 by 3. Coefficient of x square we should find. Now, the first one, it is in the form of a plus b whole square, a square plus b square plus 2ab. So 3 terms will come. Now this one here, 8 I am going to take common, 8 power minus 1 by 3, take it as a common term, then it will be 1 minus x by 8 whole to the power of minus 1 by 3. Okay, na? Check. So 8 power 1 by 3, whenever it is exponent is negative, we can write in denominator 1 by 8 power 1 by 3 means is nothing but cube root 8. Okay, na? And here 1 plus x square plus 2x. Now it is in the form of 1 minus x whole to the power of minus n, nothing but 1 plus nx plus n into n plus 1 by 2 factorial into x square plus and so on will come. Same format while you are observing here. I am writing here 1 plus n value 1 by 3 into x by 8 plus 1 by 3 into 1 by 3 plus 1 by 2 factorial into x square. X value means x by 8. Okay, na? Square, up to square is enough because we don't need x cube term. Up to square is enough. Okay, let us see this one. 1 by 8 is nothing but 2 cube root cancel, denominator 2 will be as it is. Then what is remaining? 1 plus x square plus 2x, and here this will be 1 plus x by 24 x by 24 plus 3 1 are the 4 by 3 here, 1 by 3 into 4 by 3, 2 factorial means 2 only. Here x square by 8 power 2 means 64. Okay, so that is equals to 1 by 2 into 1 plus x square plus 2x, and this one 1 plus x by 24 plus 4 by 18, 4 by 18 into x square by 64. But we have to find only x square coefficient. That means when you multiply these two, we don't need to write all the terms. Let me check. With 1, if you multiply here 1 we don't need, because it won't be x square. 1 into x term only. 1 into x square, then x square term will be. Now I am writing that x square terms only. Now x square terms I am going to write. For everything 1 by 2 is a common term. Now 1 into your square number, that means 4 by 18 into 64. 4 by 18 into x square by 64. Okay, na? So with 1 completed. Next with x square. X square with 1 only we should find. X square into 1 becomes x square plus x square. Now with x, 2x into x into x square will be. Now 2x into x by 24, 2x square by 24, third term, plus 2x square by 24. So all our x square terms only, we can take x square as a common term, or we can leave it the x square, because we need only x square coefficient. Now I am writing x square coefficient, that is equals to 1 by 2 into, in the first one 4 by 18 into 64. From the second term here, not there anything means 1 will be there. And the last one 2 by 24. So let us try to cancel it here. 4 table here exactly 16 times cancel. That means 1 by 2 into 1 by 18, 16s are. Try to multiply. 6 8s are 48, 4 here 10, here 18. So 288. It will be 288 plus 1, and cancellation here 1 times, here 12 times, 1 by 12 cancellation. Try to find LCM here. LCM is 288, because 288 will come in 12 table. So 12 2s 24, 40, yeah, 24 times will come. So this is denominator is 288. 288 into 288 1 time, numerator as it is 1. 1 into 288 is 288. Plus 12 table 288, 24 times will come, here 24. Now add the numerators. So 280 plus 20, 300, 8 plus 4, 12, 312 plus 1, 313. And denominator 2 into 288, so 400, 165, 60, 576. So this is our required answer. That is nothing but coefficient of x square. Okay, na? Check. Let us go to the next problem. 17th problem. The 17th problem is, 50 C0 by 1, 50 C0 by 1 plus 50 C2 by 3 plus 50 C4 by 5 plus and so on. Last one 50 C50 by 51. Okay, na? So we need to find its answer. Let us check. Now 50 C0 means 1. 1 by 1 means 1 itself. 50 C2, that means 50 factorial, or NCR formula, n factorial by n minus r factorial into r factorial. Okay, na? Or else we can write 50 into 49 by 2 into 1. Already denominator we have 3. Okay, na? Like this also we can write. Now this one 50C4 means 50 into 49 into 48 into 47. Up to 4 digits we should decrease, and denominator 4 into 3 into 2 into 1. So denominator already having 5. And so on, last one 50C50 is 1 by 51. Okay, na? So try to multiply everything with 51. So I just multiply and divided by 51. So multiply 51 I am taking inside. So 51 into 1, 51 plus 51 into 50 into 49 by 3 into 2 into 1. So numerator 3 terms, denominator 3 terms, we can write it as 51C3. Okay, na? Plus 51 into 50 into 51 into 50 into 49 into 48 into 47. Total 5 terms are there. Denominator 5 factorial. Or 5 into 4 into 3 into 2, and so on, plus 51 by 51 becomes 1. Okay, na? So simply 1 by 51, and this one we can write it as 51 by 1. So 51 factorial. Okay, na? So this one we can write 51C1 plus 51C3 plus 51C5 plus and so on plus 51C51. So while you are observing, these are all odd powers. We know already odd powers means C1 plus C3 plus C5 and so on equals to 2 to the power of n minus 1 format. So here also we are writing that 2 to the power of 1 by 51 as it is. We can write 2 to the power of n minus 1. Here n is nothing but 51. 51 minus 1. 51 minus 1. 51 minus 1 is nothing but 50. That is equals to 2 power 50 by 51. This is our required answer. Okay, na? So let us move on to the next problem, that is 18th one. The value of 2014 C2. This is also same somewhat like this. You can try by your own. Okay, na? So let us go to the problem number 19. 19th problem, n greater than or equals to 3, then we need to find 3 into C1 minus 4C2 plus 5C3 minus and so on plus minus 1 power n minus 1 into n plus 2 Cn. Plus 2 into Cn, or nothing but NCn. So this value we need to find, but here n value must be greater than or equals to 1. Now we are expressing this one as, this one we can take, right, that is equals to sigma minus 1 power r minus 1 into minus 1 power r minus 1 into r plus 2 Cr. Okay. So try to simplify this one. So we can just multiply Cr. This one we are writing as sigma minus 1 power r minus 1 r into Cr plus 2 into sigma minus 1 power r minus 1 Cr. Okay, na? So if you try to take that n value is 0, is not possible, right? 1 if you take means minus 1 power 1. Okay, na? So 1 plus 2, that means r value is 1 to n is possible here, sigma. R is equal to 1 to n is possible. Okay, na? So that is equals to RCR format. What is that RCR format? We can write n into n minus 1 C r minus 1 format, right? So this one sigma r is equals to 1 to n minus 1 power r minus 1. We can write n into n minus 1 C r minus 1 format. Plus this one also 2 into sigma r is equals to 1 to n, here minus 1 power r minus 1 and CR is nothing but C1, C2, C3 like this, means 1 and 1, C1 plus C2 plus C3 like this we can write. So this will be 2 into CR, that means only CR we can. Okay na? Yeah. So that is equals to, so this value whenever you can see n minus 1, CR minus 1, where r is equal to 1 to n minus 1 whole to the power of r minus 1, the value will become 0. Okay na? That is equals to, that value becomes 0 and minus 1 power r minus 1, no? So minus will come minus 2 into r minus 1, here nothing but n minus 1 or 0 minus 1. So multiply here, minus 2 into minus 1 becomes 2. So therefore the answer will be 2. Okay, so let us go to the 20th problem. If x is a positive integer, the first negative term in the expansion. So that one, first negative term in the expansion, we have to take multiple options like, so first term, second term, third term, we have to take like this. It will come 8th term, you can try by your own. Okay na? 7th or 8th term will come. Now 21st one, so that is also, yeah, somewhat easy here. So you can try, but it is a different format for you, a different formula. So 95C4 plus, the question is given that sigma j is equal to 1 to 5, 100 minus j C3 equals to 100k, 100 ck, we need to find the k value. Okay na? Now 95C4, I am just expanding j value 1, 2, 3 like this, I am taking up to 5. So that means j value 1, if I take 100 minus 1, it will be 99C3, 100 minus 2, 98C3, 100 minus 3, 97C3, 100 minus 4, 96C3, and 100 minus 5, 95C3. 95C3, that is equals to 100 ck. Okay, now I am expanding like this. Now check here these two terms, 95C4, 95C3, write it together, it is in the formula of NCR plus NC r minus 1 equals to n plus 1 CR. Same formula if I apply that, 95 plus 1, 96, r means greater 1. So 4 and 3 greater value is 4, NC4. Okay na? Again these three terms. Now last term, NC4, NC3 will be 97C4. Again this term you can write 97C4, 97C3 becomes 98C4. Again these two will come 99C4. Again these two will come 100C4. So 100C4 equals to, that means 5 steps will come one by one, but I have written directly like this. So compare k value is 4. K value is 4. So same manner you can check that last problem also, that is the direct format. So you can try by your own. So that's it for today children. Thank you one and all. Have a nice day. Bye bye.